Thanks for joining. My name is Gabriel. I'm a software engineer at Tonal, and I used to be at Airbnb. I'm just going to go ahead and assume that if you're on your laptop, you're looking up Tonal, what that is. That's fine. But today, I'm going to be up here, and I'm going to be talking about why cross-platform is terrible, and you shouldn't do it. Uh, but actually, I'm going to talk about why cross-platform is sometimes good, sometimes bad, and why you should maybe do it depending on the needs of your team. And so before I dive in, I want to talk about what this talk is not. So if you came here to get a concrete answer on whether cross-platform is right specifically for your team, I'm not going to tell you. If you came here for me to roast React Native for 45 minutes so you can go back to your team and tell them why it's terrible, I'm not going to do that either. Or if you want to deep dive into the technical pros and cons of React Native, I'm not going to do that either. You can go ahead and read our Medium blog post or various posts on the internet to find the technical specifics of React Native. But what I am going to talk about is what it looks like to build a cross-platform organization at scale in a way that'll apply to any team and any cross-platform framework. So let's go back and look through history. Let's go back to 2015. Back in 2015, there were two mobile teams at Airbnb, Android and iOS. There were two different teams building the same product, two different code bases trying to build the same thing in parallel. In 2016, when we introduced React Native, for the first time, we had engineers working on both sides. We actually introduced a third platform, React, into the code base. And based on the fact that you're here today, you probably know that we've decided to sunset it. And so this is what it looks like today. We've actually gone back, and we're back in the 2015 world. But along the way, we've learned a lot. We got a lot done. I'm actually really proud of a lot of the things we accomplished. But let's look at that a little bit more detail. We have to go back to March of 2016. This is when we first introduced React Native into the code base. This was a really interesting time for mobile at Airbnb. Mobile was becoming an increasingly important part of the business, but we didn't have enough resources to actually become mobile first. In fact, our engineering resources looked more like this. We had about 15 engineers on each mobile platform, but probably over 100 on web who knew React. Instead of having a single mobile team, we had actually started to split up the mobile team so that each feature team had the complete vertical stack of engineers so that they were empowered to ship on all platforms at the same time. Unfortunately, because we didn't have enough mobile engineers, there were entire teams who literally had no one on mobile, so they had absolutely no way to ship anything. So this is a problem. It actually came down to two engineers who saw a potential solution to this. They noticed that the right side of the scale was a lot heavier than the left side. They'd also heard of this thing called React Native. React Native was an opportunity to tap into the React expertise we had at Airbnb to allow Airbnb to ship more code on mobile. It actually made a lot of sense. So they decided to do a pilot. They picked a feature that didn't yet exist on mobile, so no matter what, having it was going to be strictly better than not. No one could make that argument. So they picked reservation alterations. They went forward with a pilot in order to ship a single feature in React Native. Actually, to get from 0 to 1 took quite a lot of effort. They had to not only introduce React Native into the code base, but they had to bridge a lot of core infrastructure to make it work well in an existing app. This had to integrate with existing native code, but also our existing infrastructure like experimentation, internationalization, our common design language, and countless other things that we had built over the years at Airbnb. So this was actually quite a feat, and they were able to get it done. And as you can see, the first screen here, that's native, and then it's going to jump to a React Native screen. You can even hardly tell the difference. So for the most part, it was a success. I mean, it wasn't perfect, and it was fairly young and immature, but it actually worked. It was around that time that Airbnb was starting to build out its first major new vertical since it launched Homes in 2008, which is Experiences. Experiences was set to launch in November of that year, but they faced the same problems that all the other teams did. They didn't have enough mobile resources to actually build and ship the product by November. So they made a big bet on React Native. And in November of that year, they shipped it. The entire experiences platform for guests and hosts was built in React Native, and it was the first thing that really solidified React Native as a major part of the code base at Airbnb. Granted, it wasn't easy. We had to build a lot more infrastructure. We worked many late nights to make it happen. But again, we were able to do it. We were able to reach all of our design goals and actually ship the complete feature set. Fast forward through 2017, we actually built over 220 unique screens in React Native. That amounted to about 80,000 lines of JavaScript product code, 40,000 lines of JavaScript infrastructure, countless more in Java, Kotlin, Objective-C, and Swift. And from the product engineer's perspective, the cross-platform dream was actually true. Over 95% of those product files in our code base didn't have a single platform split at all. And that's not to say that they worked exactly the same on both platforms. In fact, we actually put a lot of work, and some of that 40,000 lines of JavaScript infrastructure was there to actually build in a lot of the platform affordances into things like the design library and our navigation library. So they used things like activities on Android, UI navigation controller on iOS. The toolbar was going to be a toolbar on Android that responded to the scroll position, or a UI navigation bar on iOS accordingly. Even minor design affordances like chevrons appeared on iOS but not Android, but we baked that all into the infrastructure so that it was actually seamless for product engineers. We even built a bunch of features we weren't even sure were possible. We got shared element transitions working between native and React Native screens on Android and iOS, with a simple API that felt canonical to React engineers. We built screens with long lists, 60 frames per second parallax, but at the end of the day, it was about 15% of our engineering effort. Although many people thought it was more than that, and 220 screens is a lot, it still, again, only amounted to about 15%. Meanwhile, there was a lot of infrastructure there. We had minimum of two engineers working full-time to make React Native work. Throughout 2017, I was one of those two. We also worked with 6 other engineers working on Android and iOS infrastructure for support. Part of our job on the React Native infrastructure team was to work with all of the other teams at Airbnb. Many teams working with React Native didn't have very much expertise in mobile, so it is part of our job to mentor them and provide them support on native when needed. We also had to work with them to figure out when to go native or React Native, and we had to do many code reviews. As people became onboarded, we didn't have a huge community within Airbnb and made like mentorship programs and training programs. People who learned React Native at Airbnb learned it in-house. In fact, we also had a lot of internal infrastructure we built around it. So that required training and mentorship, and it really came down to us on the infrastructure team to be able to take the time to support them. Around the end of last year, though, we really wanted to take a step back and get a pulse on how things were going. So we sent out a survey to all engineering managers and engineers working with React Native. Of the engineering managers who responded, they were roughly split on whether they thought that React Native enabled to move faster or slower. Now, this is one you should probably take with a grain of salt because it's really hard to actually know this. You never build a counterfactual screen. And engineers notoriously underestimate the amount of time things take. And so if you just ask someone, they're probably likely to say that it took longer than the alternative. But if you talk to the engineers, they actually had an overwhelmingly positive experience. 15 out of the 19 engineers who responded to the survey actually said they had a positive experience. Of them, about half of them had worked with React, and about a third had worked on mobile before. And most of them would use it again. So we took another step back. We looked at where we had come and where we thought React Native might go at Airbnb, and we did some math. Turns out the math was super complicated. There were a lot of aspects of it. There were different parts here and there. And honestly, if I were to go through all of it, I'd probably be here till next year. So I'm not going to go through all of it. I'm just going to focus on one part. Have you decided to sunset it? I'm going to focus on the organizational challenges. The reason I decided to focus on the organizational challenges is because, again, they broadly apply to any team considering going cross-platform, no matter the size, or whether you're choosing React Native, Flutter, Kotlin Native, or whatever it is. So now let's dive right in. So the first organizational challenge going cross-platform is that it's simply really polarizing. I mean, you saw that first slide I had up there, right? Like, React Native is terrible, cross-platform is terrible. Even getting the Medium post out and trying to gauge people's reactions is all over the map. It's really one of those topics. It has a long history in mobile, and people have had years and years to build up opinions and thoughts about what they think cross-platform is and what it's capable of. And you have to be aware of this fact if you're considering introducing it into your organization. In fact, many cross-platform frameworks have gotten a pretty bad reputation among the mobile community. They're generally thought of something that companies invest in when they don't want to invest very much in mobile, don't have the resources to, and they're thought of as having a lot of shortcomings that prevent you from achieving the experience that you want to ship as a native engineer. You also have to remember that we're all human. Sometimes as engineers, we assume that we're super hyper-logical and rational people, and every time we have a conversation, it's purely based on the facts. And this is simply not true. We all have opinions, we're all human, and things that sound like technical conversations are actually us trying to conform to our previous beliefs in many situations. You also have to be really careful. So early on, the first few experiences you ship with a cross-platform framework, especially if you have an existing native app, you have to be extra careful with. In fact, we had one fairly bad experience early on with React Native at Airbnb that left a scar for the entire history of React Native at the company. During the experience's launch, the experiences team knew they needed to build a new itinerary so that if you're a guest booking an experience, you could view the information on mobile before you joined up with the experience. It's a pretty complicated feature. It has a lot of edge cases. It's also fairly unique in that when you have a booked experience, it's the launch screen in the app. And React Native has an initialization time, and so we actually, when they came to us to ask if they should use it in React Native, we actually told them that they shouldn't. Part of that is that there's that delayed initialization time. It's also very complicated, and we foresaw that there would be a number of challenges in reaching the quality bar at that point in time. But they didn't have the resources to build it in native, so they went forth with it anyway. It was actually originally supposed to be a prototype, but then the real one never got built. It was only tested on iOS, and then it was dropped in as a 4,500 line PR 2 days before the final branch cut. You can imagine how this probably went. We shipped an experience that was subpar. And it's not really the fault of any specific engineer. There were a lot of things that went into this. And you might think that this would never happen at your company, but these things happen, right? Unfortunately, we shipped this experience, and everyone who was ready to hate on React Native had their ammo. In addition, the screen was fairly difficult to maintain. Some of the headcount on the team changed, and they hired more mobile engineers over time. Instead of trying to fix that screen, they decided to just rewrite it in native. So all of a sudden, you had this high-profile screen within the company that was thrown away and rewritten in native. And people without the broader context could just look at that and say that this was a bad screen, and it was rewritten in native, therefore React Native is not good enough. Now, there was a lot more context involved in that, but a lot of people either aren't aware or don't really care, right? You can find whatever answer you want to if you look hard enough. The other challenge is that when you go cross-platform, you think you're going from 2 platforms to 1, but you're actually going from 2 platforms to 3. Cross-platform doesn't completely replace native. At the end of the day, you're shipping an Android and iOS app, and so different frameworks have to go into native at different degrees, but you can't get rid of it completely. In addition, the fact that you can't get rid of it completely means that no matter what, you're going to be working outside of your comfort zone sometimes. You can become an expert at Android or iOS or React, and you can spend all of your time working in that framework, and you can get so good at it that you can do anything you want. But you can't do that with 3. There's just not enough hours in the day to become true experts at all 3 platforms. In addition, you have to have 3 development environments set up on your machine. You don't really notice the overhead of having a development environment set up if you really only have to keep one up to date. But it turns out when you multiply that by 3, all of a sudden you really notice it. You'll go on vacation for 2 weeks and you come back and everything is broken. You have to spend an entire day trying to get things up to speed. And when you want to bridge some critical infrastructure, you might think it's a matter of just rewriting some APIs, writing like a one-to-one bridge. But let's take an experimentation platform, for example. It was written by an Android team and an iOS team. They were written by 2 different people, 2 different code bases, with the canonical paradigms for each platform. It's not always that simple to actually simply wrap them with a single bridge. They might not have the same API surface. There could be subtle differences in behavior. And then the one that you expose to your cross-platform framework also has to feel canonical in that. Turns out that Java, Objective-C and React JavaScript are totally different languages with different API paradigms, and trying to bridge them isn't always as simple as you might think. And in addition, sharing state is really complicated. If you have a hybrid app, it can be a challenge to move state from one side to the other. Take, for example, a search results screen in a details page. If you wanted to share some like a shell version of the information from search details to the product details page so that you can show some information before all the details loads, it's really easy if you're fully native. You can just send the data over. But if you have data living partially in the Java heap, partially in your Objective-C memory, and then partly in your JavaScript heap, what do? They're totally different languages and they can't talk to each other. You have to figure out a way to manually marshal and unmarshal that information and store it in two different places. This is a real challenge. Take another example. On Android, sometimes it'll give you a bundle to save some state. When your app is in the background to free up memory, it may actually kill your process and later restore your app in a new process with just that bundle of information. So this is actually really tricky behavior, and some Android engineers know that it exists and get it right, but some don't even know that it exists. Now think about how that applies to something like React Native. We used Redux to store our state in React Native. It's on the JavaScript side, and it communicates asynchronously over the JavaScript bridge. When Android gives you that bundle to save state, you can't do anything with it. You can't get that state back synchronously, and even if you could, you can't parcel your Redux state into something that you can save into an Android bundle because it's not serializable. Unfortunately, because of this, frameworks like Flutter don't actually handle this case, and they just wipe everything away when Android does this. In React Native, we actually had to implement something similar because there was no easy and robust way to work around this. In addition, you have to be ready to support the platform. This is not just a dependency you add to your dependencies and then let it live forever. These platforms move super, super fast. Some teams will have no native experience, so you have to support them as people. And incentives have to be aligned so that they have the actual time in their workday to devote to other teams. If the native teams are building, let's say, the next version of the networking library or experimentation library or whatever it might be, someone has to be there to make sure that those bridges also stay up to date. Otherwise, it's just going to get further and further behind. Not to mention the frameworks themselves update. React Native has a new release every few weeks, and I think it's similar for other frameworks as well. Sometimes it's pretty easy just bumping a version to upgrade, but that's not always the case. We had one upgrade last year of React Native that was particularly painful. So every version of React Native is bundled with a specific version of React. There were a series of React Native releases last year that were bundled with React 16 Beta. Now, React 16 Beta was perfectly stable on its own. It was stable enough for Facebook to use it on the main website. The problem then comes in with the broader community. One of the advantages of React Native is that we could use many of the high quality and popular packages from React Web. And we did, like Redux, for example. However, the web community has a habit of not supporting beta versions of React. There's no reason for them to upgrade until they go stable. So they all have semver version matching in their package.json that says they support React whatever, 15, 16, 16.1, whatever it might be. And they don't support the betas. So when you try to upgrade React Native, all of a sudden, you're no longer compatible with any of your libraries because of the semver version matching. This led to a tricky situation in which we had to work with a bunch of open source libraries to either have them explicitly support React 16 Beta for React Native, or fork the library and literally just change the semver version matching of the React dependency in order to get it to work. So this turned a simple upgrade into basically a month-long process in which we had to drop the other work we were doing in order to upgrade React Native and get the other upgrades we wanted. Testing is also a challenge. Right? I'm sure we've all worked on a medium to large size Android or iOS app. Android Studio and an emulator can bring a MacBook Pro to its knees. Now imagine also running Xcode, an iOS simulator, and VS Code all at the same time. You can't. It's simply not going to work. Your music is going to start stuttering. Slack is going to take like 45 minutes to load. Your computer, you're simply not going to get anything done if you try to do this. So even if you're a great engineer and you're like, I'm going to go cross-platform, I'm going to do great at testing in both platforms, your computer is going to prevent you from actually doing that. and that's unfortunate. So you're probably going to test on one, not the other. Okay. So then you test on one, and then right before you put up the PR, you just quickly boot up the other one and try it out real quick. So now you're starting to ship features that you've only smoke tested on one platform. And that's because of limitations. Like, you have the best intentions, but it's really hard to work around some of these problems. Plus, it can be really hard to find the root cause of a problem. Not only do you have one framework that you have to look at, all of a sudden you have the framework, you have a bridge, you have Android, you have iOS. There's all these different places to look. You debug them all differently, and you have to understand where to look to find a problem. I'll give you two examples. One, imagine you have UI jank. If it's just Android, you can use systrace, you can use log tags. You just basically look at the view hierarchy. You have your measure pass and your layout pass, draw pass. You can figure out exactly what's taking too long. Now, if you have the same problem in React Native, the problem could be in your component. Let's say it's connected to Redux. If you haven't memoized your Redux state properly, you might be updating your entire React component tree every single time anything in your Redux state changes. Maybe it was actually just isolated to your component and your should component update is incorrect. But let's say you did all that perfectly. It then shuffles all of your React component data to a library called Yoga. Yoga is a C++ layout engine that takes Flexbox in and it spits out Android and iOS views on the other side. It's basically a giant black box, and it's what turns your React components into a view hierarchy. What it does, basically a total black box. If you need to debug it, good luck. Now let's say it spits out these views. You can look at the layout, measure, draw, pass on Android. But what does it mean, right? You didn't create those views. They went through like 4 translation layers before it got there. So figuring it out can be really challenging. I'll give you another example. We had an instance where luckily we caught it in development, but randomly on certain devices, fast devices, slow devices, entering React Native screen, it would just render white. And then for the duration of that app session, every React Native screen would be white. We couldn't figure out why. Everything looked normal. The React root view is mounted. Our components seemed to be rendered. We were debugging like threading between the JavaScript side and the Android side. And oh my God, if you ever have to do that in React Native, God forbid, it's a nightmare. And we had multiple engineers spend multiple days to try to figure this out, and we couldn't do it. In fact, this is one of the most stumped I've ever been on a bug in my whole life. So eventually we gave up trying to actually figure it out, and we went to our favorite tool, git bisect. And we found it. Turned out that there was a little commit we had done about a week earlier, someone on a different team, in fact. We had removed the initialization of a library called Fresco. Fresco is an image loading library that enables you to load images from a network into an image view. Well, it's by Facebook, and so they bundle it with React Native, so the image component can load images from the web. Very easy. However, at Airbnb, we used Glide, and we had replaced all of the component implementations with the Glide version. So the problem was not that we removed Fresco and then Fresco broke. I know it wasn't supposed to be used in the first place, and in fact it wasn't. It was using Glide, I promise. But for whatever reason, removing the initialization of Fresco, which is a library that we weren't using, somehow randomly caused all React Native screens to render white. If you have any idea why this happened, I'm very curious because I still have no idea. The community, also a challenge. I'm sure we all Stack Overflow like a million times a day. If you have any question on Android, you can definitely find the answer online. There's over 1 million Android tags on Stack Overflow. The community is about a decade old, and it's super mature. There's blog posts, Twitter, conferences like this. There's so many resources to tap into for native. But compare that to about 36,000 tags for React Native and 4,000 for Flutter. In fact, these platforms are also younger and really fast moving. So if you do find an answer, there's a good chance that it's out of date, deprecated, or doesn't work in your project. This is a real challenge. In addition, the 3-platform challenge rears its head in open source. If you're an experienced Android or iOS developer, you can build a really high-quality open source library by yourself. But it's much harder to do that in a cross-platform world. Almost every single cross-platform library has code in all 3 platforms, and you minimally have to have build, deploy, and packaging steps for all the platforms. And it was really, really obvious to us when we used a handful of open source libraries in React Native that even if they were high quality on one platform, there was usually one of the three platforms in which the code was of very low quality, buggy, or often behaved in unexpected ways. Again, this is a real challenge, and it's, you could have a great engineer, but it's simply impractical for someone to write excellent code across three platforms. In addition, this is a question we had to answer about 1,000,000 times. Do you go native or React Native? Every single team at Airbnb encountered this question at some point, and over the span of 18 months, we never figured out an easy answer. It turns out it's super complicated. It depends on what you're trying to build. Depends on who's on your team now. It depends on who you think might be on your team in 18 months. Good luck figuring that one out. It depends on who you have to integrate with. It depends on so many factors. Answering this question is just like, are you ready to answer this question over and over and over again? It's like you have to be patient, and you have to be willing to put in the work to figure this out, because it's not easy. And then from the perspective of those managers, they need an answer to this question, because they know they need to build a feature. They don't really like their output metric is like, is this feature going to get built? But the answer to the question of native or React Native totally changes the number of engineers they need and what kind of engineers they need to hire. And often these engineering managers are full stack engineering managers without very much mobile experience. So you have someone without a lot of experience trying to make these decisions ahead of time without all the information necessary to answer the question. And there's not really even a right answer. Plus, at the end of the day, you don't even know if you got it right. It's a real challenge. And at the beginning, we're like, wow, we have all these React engineers. They're just going to start working on mobile now, right? That's great. That's basically the whole point of React Native. Well, we didn't see that as much as we expected. And I think that there are a number of reasons for it. But first of all, engineering managers have to account for the fact that the React engineers can work on mobile. When they do resourcing, they give everyone projects. And someone has to have the foresight to think that, oh, this person working on web can also work on mobile. But then from the engineer's perspective, mobile has historically been a black box. Android and iOS take a long time to learn. Different languages, there are different frameworks. If you're a web person and there's like a mobile team over there and they're doing their thing, it's a total black box. It takes a real mental shift for them to even consider the fact that they can ship on mobile. That being said, we did see some web crossover. One of the last projects we did in React Native, we worked with one of the best React engineers at Airbnb. It was one of the coolest projects I've ever worked on. He got up to speed in React Native in about 3 days. He then proceeded to write one of the highest quality screens we ever shipped in React Native. It had a long list. It had parallax. It had 60 FPS animations. It had videos that auto-played and paused as you scrolled up and down the page. It was basically perfect, and it was one of the most beautiful screens in the whole app, and you would never know that it was React Native. After he built this, he would then wrote the web version and mobile web version in about half the time it would have taken him otherwise, because everything he had already planned out, from the Redux state to his reducers to the componentry to the organization of the page, carried over almost perfectly to web and mobile web. So this was the first and only time we had a single engineer ship across all 4 platforms. It was an amazing experience, and it undoubtedly saved an incredible amount of time. He was so sold on React Native that he was one of the most disappointed people when we announced that we were sunsetting it shortly after. But now, think about it. These React Native frameworks or cross-platform frameworks, they take a little bit of extra work to get right. You're going to have to test it on 2 platforms. They're a little more immature, so you're going to have to deal with a few things here or there. Let's say it takes you a week to build something on Android, but a week and a half to build it in React Native or another cross-platform framework. From your perspective, it's quite a lot longer. But from the organization's perspective, 2 engineers spending a week on something is less time than you spending a week and a half. But it's often the engineers who get to make the decision on what framework to use. So you have these 2 different sides of the coin, and depending on the way that you look at it, you might actually get a different answer. And finally, a major thing that we didn't really consider until the end of our time with React Native is how it affected hiring. As it turns out, if you start talking about using a cross-platform framework in the open, people are just going to start assuming that 100% of your app is written in that framework. As you now know, it was only about 15% for Airbnb. At any given point, again, 85% of our app was Android and iOS engineers, despite the fact that a lot of the external community thought that we were a React Native shop. We proved this when, after the Medium post, our mobile applications went up by 50%. This is a really, really big difference. We had no idea what an impact this was making, but it's something you really need to consider. In addition, if you decide to go 100% cross-platform, once your app reaches a certain size, you're probably going to want some sort of Android or iOS expertise so that you can ship a high-quality app and you can dive into native when it's appropriate. Finding really high-quality Android and iOS engineers is hard, period, but it's even harder if you have to convince them to work on a team that's entirely cross-platform outside of what they do. In addition, you have to go all the way down to recruiting and make sure that they're trying to hire the right people, right? If they're continuing to just look for Android and iOS people, meanwhile you're trying to build a React Native team over in the corner, they're just going to keep hiring iOS and Android people, and your relative percentage of the mobile organization is going to shrink over time. And that's actually exactly what happened at Airbnb. So when we take a step back, we started working with React Native in 2016. We decided to sunset at the beginning of 2018. Did we fail? We shipped 220 screens. We launched the entire vertical of experiences. It was generally a really good experience, and we learned a ton along the way. In fact, we did a bunch of things that were truly bleeding edge. The ability to write a line of code and have it show up on Android and iOS like a second later, that's incredible. And now that I'm back on Android again, I actually really miss the days of hot module reloading. It really worked. It even worked at Airbnb scale. And at times, it really, really felt like we were years in the future. We were working on building our own code push in-house. Code push was at first going to allow us to ship over-the-air updates to fix crashes and bugs for users in the wild. But we had long-term plans to get to a point where we would actually be able to consider continuous deployment on mobile the way that our backend engineers have come to expect. This is a total game changer. And unfortunately, we're not going to get there at Airbnb, but the fact that these frameworks exist mean that other people are still working on these problems, and they're going to push the industry forward. So even though we're sunsetting React Native, I don't think we failed. In fact, it was kind of fun. We learned a lot, and I'm really proud of a lot of the work that we did. In fact, we took some of those learnings, and I want to talk a little bit about that now, because I do have one more thing. This one more thing is called Mavericks. Mavericks is a library that we open sourced on Android about a month and a half or two ago. It's probably the most exciting framework I've ever worked on, to be honest. It's an architecture library built on top of Google's architecture components, built for Kotlin, and it was designed to make building product on Android easy and fun. A lot of these frameworks, MVC, MVVM, MVI frameworks, whatnot, they're designed to be academically pure and super testable, and like you read the README and they talk about actors and interactors, and they have giant state diagrams and all of this philosophical stuff. But now, over the last 6 years that I've been doing Android and React and seeing other frameworks, I just started to notice these patterns. Things that people do over and over again. And I just wanted to help people write better apps. And I know what you're probably thinking. You came here to learn about cross-platform frameworks, and now I'm talking about Android and another architecture pattern. And I am. It's really exciting. But I want to do this because I'm excited. But don't take my word for it. We sent a survey to the engineers at Airbnb who had used it. In fact, these were just the first 14 during the pilot. 13 out of the 14 gave it an 8 out of 10 or higher. And here are the number of screens in the Airbnb app that were shipped with Mavericks. This was the pilot that went through sometime in July. As you can see, we saw steady growth as the teams who adopted it continued to use it, but we capped it at just a few teams. But when we opened it up to the rest of the Android team, it took off. In fact, in just another month or two, there are going to be more Maverick screens in the Airbnb app than there were React Native screens after 18 months. So let's see what it looks like. We're going to build this Hello World screen. I want to caveat this by saying we're going to build a Hello World screen, and it's really easy to make a Hello World screen look good. It demos really, really well in almost any platform and framework, as it turns out. But I want you to take my word for it because we were continuing to use Mavericks for the most complicated screens in the Airbnb app. We're now using it at Tonal as well. And in fact, the screens that adopted it at Airbnb, those complicated screens, did it because it helped them simplify things. They do advanced things like pagination, prefetching, gestures, tabs, maps, videos, you name it. They're super complicated screens, and they chose Mavericks because it actually helps them at that scale as well. So this is one version of the code. I don't want to spend too much time on it because I want to show you specifically how well Mavericks works with the other library we open sourced about 2 years ago called Epoxy. Epoxy over time has evolved. It was actually originally built for making heterogeneous screens with recycler views. Turns out the recycler view is great. It has a lot of options, but it was mainly designed for having just a few items on screen. Turns out if you can make it really easy to build a heterogeneous screen, it becomes very powerful very fast. Over time, it's iterated a fair amount, and actually it's converged quite a lot with React. So let's take a look at what the same screen looks like with Epoxy. There it is. That's all the code. As you can see, we start with a fragment. A lot of people are moving away from fragments, but bear with me. Turns out that Google's reinvesting in fragments. They used to cause a fair amount of problems, but honestly, at Airbnb, they work pretty well, right? They're not perfect, but they work. When you go to Stack Overflow, you'll find your answer. And behind a lot of the complexity is a lot of power. So if you can find the right way to abstract the complexity, it's okay to use fragments. And here we have build models. If you know React, this is very similar to the render method. You return a list of components that get rendered to the screen. One thing to note here is that this header, which I'll show you how that works in a second, that's not a view. It's what's called an epoxy model, or similar to a React component. This is just the data representation of your view. Epoxy will then diff it on a background thread and only dispatch the necessary recycler view updates to make the screen go from where it is today to what you return from this method. So this is how you make the header. It's just a custom view. It extends frame layout. It has a title view. It's pretty simple. You just annotate it with model view at the top. That model view is going to tell Epoxy that you want to make an epoxy model out of it. Again, epoxy model is kind of like a React component. It will generate a recycler view holder layout, and epoxy model for you automatically. You then annotate the properties that you want to be able to set on your epoxy model. So here we have one for title. Annotating a text prop will actually, because this is built for Android, it will create the overloads for string resource ID, string, or char sequence for you automatically. And that's where title comes from on the left. Now let's look at what the screen looks like when we add Mavericks. So first, we need to define a state class. The state class should have all the information necessary to render your screen. Here, it's called myState. It has one property called the title, and we're going to initialize it to hello world. We then need to create a view model. This view model extends the Google Architecture Components view model, so you can leverage all of the improvements and infrastructure that they're building around that. But you'll notice that it's generic on a state class. That means that the view model has a singular state that you observe. No more messing with live data or anything like that, or individual properties, a single state class for your screen. Now this initial state is also quite interesting. It's going to populate it at first with the initial value. But remember that thing I talked about where Android will give you a bundle and actually recreate your app in a new process with that save instance state? Turns out that Mavericks uses that under the hood to give you an initialized state from the previous process in your app when you come back again. So we actually handle that automatically in Mavericks. We then call a function called getExcited. It has a setState method that's very similar to setState in React. You pass it a reducer. Instead of a reducer, the this inside of the reducer is the current state, and it returns the new state. So here our state is a data class, so that copy is the copy function from a Kotlin data class. So it's essentially returning a new copy of the current state with an exclamation mark appended at the end. We then have our fragment, and we're going to get the view model. Notice very carefully here that we're not creating an instance of the view model ourselves. This is because we're leveraging the architecture components way of using a view model provider. With a view model provider, if you rotate the screen, if you go forward and come back, or come back in a new process, you want to get that same view model back. And so if you do something like execute a network request, you don't have to resubscribe or do anything like that when you rotate. It's also automatically going to subscribe to any changes in state and then call a function called invalidate. Here we've wired up invalidate to build models because we're just using it with epoxy. And then here we get our state. There's a reason. You can check our wiki of why we have with state in that syntax, but there is a reason for it. And we return our header. Going back for a second here, you notice it says fragment view model. That means it's scoped to the fragment. Often, in order to share data across fragments in the same activity, people do crazy things with Dagger, or you create a custom activity where the activity owns something that can be shared. With Mavericks, you just replace fragment view model with activity view model. And then every time you request a view model of that class from the same activity, you'll get the same instance and automatically subscribe to the same values, so that as you move between a flow, sharing data is seamless. Now you can have a single activity that knows nothing about any of your features, and each screen only needs to know about the data that it needs. But let's make it a little bit more complex. Let's pretend like we have to fetch the title from the network. So the first thing we're going to do is go back to our state class and replace string with async string. Async is a Kotlin sealed class that ships with Kotlin. It has 4 subtypes: uninitialized, loading, success, and fail. And it's generic on the success type. We then are going to change our getExcited method to execute a request. This is just going to be an observable of string. And now Mavericks has an extension function on observable called execute. What execute does is it maps an Rx stream of data to a singular stream of async. So it's going to emit loading at the beginning, then it's going to map on next to success and on error to fail. So actually with this one line of code, you have the on next and on error and on complete all handled implicitly. So now your UI can just react. It can check if it's loading, it can check if it failed, it can do whatever it needs to render the data. If we go into the build models method like we had before, you'll notice now that instead of calling state.title, we're invoking it. And that's because async itself overloads the Kotlin invoke operator, so you can just call it like a function. And it's going to return a nullable version of its success value. So for loading and fail, it's going to return null. And for success, it'll actually return the successful value. You can then show a loader if it's null and show the title if it's successful. And there you have it. That's all the information you need to execute a network request, handle the loading state, handle the failure state, and render it on screen. So to recap there, we have Mavericks. Mavericks takes a lot of our learnings from React Native, as well as years and years of Android. It abstracts away a lot of the Android lifecycle problems, and almost everything that you saw actually happens off the main thread. Build models off the main thread, diffing off the main thread, set state off the main thread. The threading model was built into the fundamental architecture of Mavericks so that you don't have to think about it. But almost nothing actually happens on the main thread. It's also Kotlin first and Kotlin only. The important thing about Mavericks is we wanted it to be fun, easy, and fast to build Android products. And we knew that in order to get the API right, we had to go with Kotlin. It's super easy to incrementally adopt. It's just a fragment, it's just a view model. You can have it in one screen in the middle of a flow and incrementally adopt it over time. It works great the more you use it, but you can certainly start with just as little as you need. It even handles complicated cases like Android process restoration. And for one specific internal project, it actually went from 2,400 lines of code to just 600 for the exact same functionality. And we rebuilt the Google architecture blueprints to do app, which are generally about 1,500 lines of code, and about half that with Mavericks. And so that's Mavericks. You can find it on GitHub. I'm only sharing this because I'm super excited about it. It's the most fun I've ever had working with Android, and it actually takes a lot of the learnings that we've had over the years. But that's about all I have for today. Thank you for joining me. I hope you learned a little bit about cross-platform. I tricked you at the end with some Android stuff, but I'm going to stick around for questions if you have any at the end. Thank you.